Okay. See, first we started with mechanical system. Okay. We started mechanical system. We studied two types of mechanical system, that is translational system and rotational system. We started. Okay, students, if anyone find any my voice is not audible, if I'm writing out of range, these things now, please interrupt me. Okay, just inform me. Okay. I may not be knowing because camera I have kept too high. Okay. The mechanical system we started with, it is of two types, translational and rotation. In translational system, what are the elements we studied? Mass, dashpot, and spring we studied. In rotational system also we studied the same thing. Instead of mass, it was torque, dashpot, torsional dashpot, and torsion spring we studied. Okay. With the help of these things, what we studied? We studied the circuit was too high. We used to find out differential equation. Then we found out transfer function of the system. Then we found out analogous system. This is what we did it in our first one. It was easy when there was two mass, two dashpot, two friction, like that. If number of elements started increasing more and more, what happened? Number of differential equation was increasing. If three mass is there, three set of displacement we'll have. So we will have three differential equation. So by the time we complete the problem, we will be able to get around 12 to 13 equations. So when the number of masses, if it is increased to 5, what is our condition? 5 differential equation in the beginning we will get. By the time we find out it's analogous, the circuit will increase, the number of equation will cross beyond 20 to 21, right? So when the components started increasing, we found it difficult to solve the problem. We found it difficult to find the differential equation. Then we slowly entered into a new technique called as block diagram reduction. In this, what we did? The effect of the element, we put it in one block and we call it as G. G was the gain of the block. Okay. The main task of doing all these things in control system is to find the transfer function. What is a transfer function? It is the ratio of output by input. Any system we start working, main thing we will find the transfer function. Example, if I am using this pen, okay, if I am using this pen, if the pen is manufactured, how long it can write is the output. How long? Until the ink is there. Okay, until the input is there, it will write. So any device that is existing on the earth should have the transfer function. We should be able to find the transfer function of that. Okay. Then what we did, we have started using this technique called block diagram reduction in order to find the transfer function. We have given an input. We want an output. Control system we are using, usually we work on a system closed loop system, so that our output, what we are getting is the desired one. Okay. Then the part of the output is now given to the circuit. And I call this as my feedback circuit as my H. So now what I did, this entire thing, I started putting the effect of it, I started putting in terms of block. What purpose I'm doing this? In order to find the transfer function. Now there are so many elements here. What will be the transfer function? C by R. What it will be? G divided by 1 plus or minus G into H. Hope you people remember this. Yes.
Yes, ma'am.
Okay. Okay. By the time you see, from we know this how to do. We started with one problem where we had one input, one output. First problem of our block diagram had one input, one output. In between we had so many blocks. We applied all our rules and we started to reduce that. We had 10 different blocks, series, parallel, we converted so many things we did in order to bring back into this form. So that my task was to find the transfer function. In your block diagram, you found a transfer function, okay? First problem was very simple when compared to your 10th problem. Am I right? Is your first problem and 10th problem little bit, 10th problem you're feeling little bit difficult to reduce it? You felt that pain,
Yes.
right? We went wrong somewhere. We had so many takeoff points. Then we were by looking at it, we don't know which I should shift first, where I should shift, beyond, behind. Summing point was there, takeoff point was there. Then we had two input, one output we had. Then we did another problem where we had two input and two output. As we started in this block diagram also, we started facing some problems because number of blocks increases. That reduction, we were feeling difficult to reduce it. Then another step we will move from this block diagram. We are going to move into a next stage called as signal flow graph. Here what we are going to do is, whatever the blocks are there, I am going to write in terms of a signal. In terms of signal, I am going to measure that. Okay, we are going to represent them in terms of signal. Then what is this? Is signal. How they are flowing. Okay, how they are flowing depending upon the direction of signal flow. You are going to draw the graph. Okay, this is called as signal flow graph. In signal flow graph, we have two types. First one, equation will be given. You have to write the signal flow graph. Second one, block diagram will be given. You have to write the signal flow graph. Any problem? Any issues? Pratyusha?
No, ma'am.
Some disturbance I heard. Okay, we are going to find the transfer function using signal flow graph. Okay. For that, we have to learn certain terminologies. Okay. Now let's see how to draw the signal flow graph. See, now I will have an expression V is equal to IR. V is equal to IR is an expression. For this, I have to write the signal flow graph. Based upon the number of terminals present here, we have to write the nodes. Here, I'm going to write first node for the current. Second node, I'm going to write for the voltage. That means this is the input. This is the output. Okay. In between this, I have to connect it using a straight line. Okay. Then, what is my expression? At V, I have to get I into R. So, from at this point, I should get this current along with this R. This is called as signal flow graph for this equation. So at the output, V is equal to IR, I want. So how they are flowing? They should reach the output. This is called as signal flow graph. Okay. So definitions and all, I have sent it in notes. From the notes, the PDF what I've sent, you should write it in your notes. Is there any issue for you people, like you don't have pen, paper, book and all? Is there any issue such like that?
No, ma'am.
No. Okay. Now I'm going to teach you all certain terminologies. Okay. Is all the 6 nodes invisible to you people? Oh, 5 nodes also is sufficient. If you have 5 nodes visible, fine. 6 node later.
Yes, ma'am.
Okay. First point, first parameter what we are studying is source node. First one is source node. Source node is nothing but input node. Source. Source andre no starting point. Okay. This is called as source node. So your source node is X naught. Visible alvenappa elrigo? Source
Yes,
node
ma'am.
is input node. Okay. Source node andre eno? Source andre eno? See, your library is a source. Andre eno? Everything he is ready to give. That node will act as a donor. Always he likes to give. He's not accepting anything. You can see this now. This is the starting node. He's only giving out the signal. So this X naught is the source node. Okay, now next, second point. Second one is sync node. Sync node. Sync node means what? He is an accepting node. He will only accept. See this X naught you can see here. This X naught, can you see?
Yes, ma'am.
Yes, ma'am.
This is called as output, or you can also say it as X6. Is an accepting node. Okay. Next. You understood these two? Sync node means accept last node, whichever it is the last point. Your C of S you can say. So if you did not understand this, if you have any problem here, you can consider this X7 as my sync last node. Whichever is last node, that you call it a sync node. Whatever the name it is. ಅರ್ಥ ಆಯ್ತಾ? ಎಲ್ಲಾನು ಅಕ್ಸೆಪ್ಟ್ ಮಾಡೋದು ಸಿಂಕ್, ಎಲ್ಲದು ಕೊಡೋದು ಸೋರ್ಸ್. ಇದು 2 ಪ್ಯಾರಾಮೀಟರ್ಸ್ ಅರ್ಥ ಆಯ್ತಾ?
Yes, ma'am.
Okay, next one. Next one is very, very important. Next one is forward path. Third one is forward path. What is the forward path? Forward path means it should start from one point, travel along till the destination it has to travel without tracing repeat. Back ಹೋಗಬಾರದು, repeat ಆಗಬಾರದು. Source ಇಂದ destination ವರೆಗೂ travel ಮಾಡಬೇಕು without repeating the path, without tracing the path. ಅರ್ಥ ಆಯ್ತಾ? Did you get what is forward path? I'll show you.
Yes, ma'am.
Okay. Now I will draw the first. I don't know how many paths is here, but now I will draw one. See, it will start from the source. This color is visible.
Yes, ma'am.
Yeah. It will see from x0 to x1 it will travel. From x1 to x2 it is traveling fine without any obstacle or without repeating the path. It should travel till the destination. Adu forward path. Artha aita? So now I will write forward path na nan usually T1 anta represent ಮಾಡ್ತೀನಿ. My first forward path. Okay. How I will write that? x0 to x1, x1 to x2, x2 to x3, x3 to x4. Are you getting it how it is? Forward
Yes,
path.
ma'am.
But this is very, very important. If you don't understand at this moment, you ask me. First forward path. Okay. Next forward path. Next forward path. See, x0 to x1. Okay, fine. I will go like this. Okay. x1 in the x3 or go ಹೋಗ್ಬೋದಾ? See the direction. I can
Yes, ma'am.
travel like this. Yeah, I will travel fine. Okay. Next, x3 to x4 I can travel.
Yes, ma'am.
x4
Yes.
to x5 I will travel. x5 to x6 I will travel. x6 to x7 I will travel. That is my second transfer path. Second forward path. Can you say me the second forward path?
X1 to X3, ma'am.
x2 to x3.
3 to x4.
Diagram is visible alva? Mostly computer use ಮಾಡೋರಿಗೆ ಸ್ವಲ್ಪ ಕಷ್ಟ ಆಗ್ಬೋದೇನೋ. Okay pa, ಹೇಳಿ. This green line you follow and you say me. x4, x5, x6. This is second forward path. Okay now. Okay ಹೇಳಿದ್ರೆ ಮುಂದಕ್ಕೆ ಹೋಗ್ತೀನಿ.
Okay, ma'am.
Ma'am, can you see it again, ma'am? Second part.
Yes. See this green line, you can see this green dark one. It is starting
Yes, ma'am.
from source. Starting from the source. See the direction. I can travel like this. Yes, I can travel like this and go. I should reach the destination.
Ma'am, should we not consider x2, ma'am?
You should not consider x2
X2.
ಆಯ್ತಲ್ವಮ್ಮ. Path is over, no? ನೀನ್ ಆ ಪಾತೆ ತಗೊಂಡ್ರೆ ಮತ್ತೆ ರಿಪೀಟ್ ಆಗುತ್ತಲ್ಲ, ಮತ್ತೆ ಫಸ್ಟ್ ಪಾರ್ಟೇ ಬರುತ್ತಲ್ವಾ?
Got it.
Got it, no? Okay, fine. Next, third forward path. Try, anyone try? Third forward path. You say, I will trace.
x0 to x1.
One ನಿಮಿಷಮ್ಮ. Same ima?
x0 to x1.
Okay.
x1 to x2,
Okay.
x2 to x4,
X2 to
x4,
X4 ವರ್ಗು ಹೆಂಗ್ ಹೋಗ್ತೀರಾ? X2 ಇಂದ X4 ವರ್ಗು ಹೆಂಗ್ ಹೋಗ್ತೀರಾ? ಇದು ಯಾರು ನೋಡು, ಇದು ಅಪೋಸಿಂಗ್, ಇದು ಟ್ರಾವೆಲ್ ಮಾಡಕ್ ಆಗಲ್ಲ, ಅವ್ನ್ ಅಪೋಸ್ ಮಾಡ್ತಾನಲ್ವಾ?
okay ma'am.
ಹೇಳಿ, ಕರೆಕ್ಟ್, ಹೋಗುತ್ತೆ. X2 ಆಯ್ತಾ? X2 to X3
X2 to X3.
ಆಮೇಲೆ
X5.
X5 ಆಮೇಲೆ
X5 to X6.
ಇದು ಬರೆಯನ್ವಾ? ರೆಡ್ ಕಲರ್ ಇರೋದ್ನೇ ರೆಡ್ ಲೈನ್ ಇರೋದು ಹೇಳಿ. X0 to X1, X1 to ಹೇಳಿಪ್ಪ. ಕಾಣಿಸ್ತಿದ್ಯಾ ನಿಮ್ಗೆಲ್ಲರಿಗೂ?
Yes, ma'am.
ಸೇಮಿ. X3 to
X2.
Did you get this third one?
Yes ma'am.
Yes, ma'am.
Any other forward path? See, if it is opposing, I cannot go. I cannot travel like that. That is opposing. Next forward path idre nodi heli. ಅಷ್ಟೇನಾ ಫಾರ್ವರ್ಡ್ ಪಾತ್ ಇರೋದು? X0, X1, X1, X2, X2, X3, X5. ಆಯ್ತು. ಅರ್ಥ ಆಗಿಲ್ವಾ? ನಾನ್ ಟ್ರೇಸ್ ಮಾಡಿ ತೋರಿಸ್ತಾ ಇದ್ದೀನಲ್ವಾ? ನಾನೇ ಇಲ್ಲಿ ತೋರಿಸ್ತಿದ್ದೀನಲ್ವಾ? ದಟ್ ಮೀನ್ಸ್ ನೀವ್ ಯಾರು ಮಾಡ್ತಿಲ್ಲ ಅಂತ ಅರ್ಥ. X0 to X1. Can you see this color? ಇದು ಕಾಣಿಸ್ತಾ ಇದೆಯಾ?
Yes, ma'am.
Okay. See, X0 to X1, X1 to X2, X2 to X3 ತಗೊಂಡು ನೆಕ್ಸ್ಟ್ ಈ ಪಾತ್ ತಗೋಬೋದಾಗಿತ್ತಲ್ಲ. This red one is there, no? Same you can follow. See, X0 to X1. This is forward path, ಅಲ್ವಾ? ನೆಕ್ಸ್ಟ್ ಇಲ್ಲಿಂದ ನೆಕ್ಸ್ಟ್ ಫಾರ್ವರ್ಡ್ ಪಾತ್ ನಾನು ಹೇಗೆ ಹೋಗ್ತೀನಿ? ಹೀಗೆ ಹೋಗ್ತೀನಿ. ಆಯ್ತಾ? ಇಲ್ವಾ? ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂದ್ರೆ ಹೇಳ್ಬೇಕು. I will write, so most probably you will know it if I write X0 to X1, X1 to X3, X3 to X5, 6, X7. See this? ಇದು ನೋಡಿ, ಟ್ರೇಸ್ ಮಾಡಿ. ಇದು ಟ್ರೇಸ್ ಮಾಡಿ. T4, X0 to X1. See the direction of your arrow mark. X1 to X. Is it repeating anywhere? Reverse ಹೋಗ್ತಾ ಇದೆಯಾ? ಇಲ್ಲ. Okay. This is forward path. Did you all get it?
Yes, ma'am.
Yes, ma'am.
Oh.
Yes, ma'am.
Forward path ಆಯ್ತಾ? Next one, feedback loop. Feedback loop. So you people know what is a feedback. Now you have to answer me what is a feedback loop here. Feedback loop ಅಂದ್ರೆ ಏನು? Feedback loop ಅಂದ್ರೆ ಏನಪ್ಪ? start from the point, travel through some other point and reach it at the same point. ಎಲ್ಲಿ ಸ್ಟಾರ್ಟ್ ಆಗಿದೆಯೋ ಅಲ್ಲೇ ಬಂದು ಎಂಡ್ ಆಗ್ಬೇಕು, ಬಟ್ ಟ್ರಾವೆಲಿಂಗ್ ಥ್ರೂ ಸಮ್ ಅದರ್ ನೋಡ್ಸ್. Okay. See, to draw the feedback, you know the direction. See this, I have 1, 2, 3, 4, 5 loops ಇದೆ. ಈ ಡಯಾಗ್ರಾಮ್ ನೋಡಿದ ತಕ್ಷಣ 5 loops ನನ್ ಕಣ್ಣು ಕಾಣಿಸ್ತಿದೆ. ನಿಮ್ಗೆಲ್ರಿಗೂ ಕಾಣಿಸ್ತಿದೆಯಾ 5 loops?
Yes, ma'am.
Yes, ma'am.
Loop ಅಂದ್ರೆ ಏನಪ್ಪ? It looks like loop, but loop ಅಂದ್ರೆ ಏನು? It should start from one point. See now, it is starting at x0. Very good. Travel till x2, x1 ಇಂದ ಸ್ಟಾರ್ಟ್ ಆಗಿ x2 ವರ್ಗೂ ಬಂದು from x2 to x3. Very good. Fine. Next ಏನಾಗ್ಬೇಕು? x3 ಇಂದ back to x0 x1 ಬರ್ಬೇಕು. Is it coming back? Is it coming back
No,
here?
ma'am.
No. So this is not a loop. That is not a feedback loop. Next, e loop ba. x3 to x4. x4 to x5. Yes. Then what it should do? From x5 it should come to x3. Is it coming?
No, ma'am.
So that is also not a feedback loop. It looks like loop, but it is not a feedback loop. Okay. Next loop. x5 in the start agi, x6 orgu hogi, then again it is coming back to x5. Correct?
Yes, ma'am.
So it is a feedback loop. So my first feedback loop is x0 to x5, x5 to x6, then to back to x5. Artha aita feedback loop?
Yes, ma'am.
Yes, ma'am.
Next, any other loop is there? You just say me the value. Any other feedback loop is there?
X2 to X4.
X4.
And back to x2. x2 to x3, x3 to x4, back to x2. So this is feedback loop. Feedback loop artha aita?
Yes, ma'am.
Next one bandu self loop. Self loop means which one? Which should start at one point, end at same point, no other intermediate point should come. See this x3 nodi, illi idella, x3 ಇಂದ ಸ್ಟಾರ್ಟ್ ಆಗಿ x3 ಗೆ ಬಂದು ನಿಂತ್ಕೊಂಡಿದೆ. ಕರೆಕ್ಟಾ?
Yes, ma'am.
That is self loop. Next one is path gain. Path gain. To find this path gain, we should go back to the forward path. ಈ path gain ಅಂದ್ರೆ ಏನಪ್ಪ? Path ಅಂದ್ರೆ ಏನು? Forward path. Source ಇಂದ destination ವರ್ಗೂ travel ಆಗ್ಬೇಕು. Okay, that is path. Okay. Forward path means all straight traveling data only I will take. Okay. Next. Next what they are saying is we have to find out path gain. Path gain ಅಂದ್ರೆ ಏನು? ಇದು ಮಧ್ಯದಲ್ಲಿ ಇರೋ gain ನ ನಾವು multiply ಮಾಡ್ಕೋಬೇಕು. See, they have given it now. Okay. This I forgot to write. They have given it. 3, 4, 5. 3, 5. 3, 5. Okay. This is gain. Suppose in place of this, it can be 5, 6, 7 and all. We can. That we are based upon the problem, we are going to do that. For now, we have to find out path gain. This is also called as forward path gain. Okay. How to find out this? For that, we need our forward path expression. That is forward path equation. Okay. x0 in the x1 or ಏನಿದೆ gain? How much is gain from x1 into x1 to
One.
x2? What is the gain? x0, x1 to x2, what? Next, x2 to x3.
T2, 3.
Next, x3 to x4. Like that, all the gain I will multiply. Like this, all the gain I will multiply. This is called as path gain. If I multiply, what I will get is called as my path gain. As this is with respect to forward, we will call it as forward path gain. Okay. Next, semi for path gain for the second forward path. x0 to x1 it is 1. x1 to x3 what it is? x1 to x3.
T1, 3.
T1 3.
3 to x4.
T3, 4.
Okay. Like that it is. Okay. If their values are there, that value we have to multiply. So forward path gain banta ellarigu. Path gain heng kandidiyodu anta gottaita?
Yes, ma'am.
Is there anyone who did not understand that? Signal illa, kelistilla, artha agilla, enadru idre ಹೇಳಿಪ್ಪ. Shall we go to the next topic then?
Yes, ma'am.
Okay. Now,
Tomorrow.
huh? Are you speaking to me or some disturbance? Okay, pa. Next one is non-touching loop. Next one is non-touching loop. Non-touching. Do you know what is a loop now? Yes. How many loops we found out here? x2 to x3, x3 to x4, and then x2. This is loop 1. I will call this as loop 1 is equal to x2, x4, and x2. I will consider this as loop. One more loop I have, that is x5, x6, x5. This is my two loops. Okay. What is my work is how to find out non-touching. Non-touching andre ಈ ನೋಡ್ಸ್ ಇದೆಯಲ್ಲ ಯಾವ ನೋಡು ಕಾಮನ್ ಇರಬಾರ್ದು. See, if I consider this second loop, is there any x2 loops here? ಇಲ್ಲ. Any x6? Is it common? See, any touching point is there. If any one point, if it touches, then we will not consider it as non-touching loop. See, this loop is separate. This loop is separate. Alva? This loop is separate. This loop is separate. ಅರ್ಥ ಆಗ್ತಿದೆ ನಿಮಗೆ ನಾನ್ ಟಚಿಂಗ್ ಲೂಪ್ ಅಂದ್ರೆ ಏನು ಅಂತ? ಈ ಲೂಪ್ ಗಳು ಯಾವುದೇ ಯಾವ ನೋಡು ಟಚ್ ಆಗಬಾರ್ದು. ದಟ್ ಇಸ್ ನಾನ್ ಟಚಿಂಗ್ ಲೂಪ್. ಟಚಿಂಗ್ ಲೂಪ್ ಅಂದ್ರೆ ಏನು? ನೋಡ್ಸ್ ವಿಲ್ ಟಚ್. ಎನಿ ಒನ್ ವಿಲ್ ಬಿ ಕಾಮನ್ ನೋಡ್. See, I will draw a simple diagram here. Okay, this I will call it as loop L1. This is my L1 loop, L2 loop, L3 loop. Okay, now I will say L1 and L2 is non-touching. L1 and L3 is non-touching loop. L2 and L3 is touching loop. ಅರ್ಥ ಆಯ್ತೇನಪ್ಪ ಎಲ್ಲರಿಗೂ?
Yes.
ನಾನ್ ಟಚಿಂಗ್ ಲೂಪ್, ಟಚಿಂಗ್
Yes,
ಲೂಪ್
ma'am.
ವೆರಿ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡುವಾಗ ಇದ್ರಲ್ಲೇ ನಾವು ತಪ್ಪಾಗೋದು. ನಮ್ಗೆ ಎಲ್ಲರಿಗೂ ತಪ್ಪಾಗೋ ಪೊಸಿಷನ್ ಇದು. ಯಾವ್ ಟಚ್ ಆಗ್ತಿದೆ, ಯಾವ್ ನಾನ್ ಟಚ್ ಆಗ್ತಿದೆ ಅಂತ ಗೊತ್ತಾಗ್ಬೇಕು. ಸೊ ಇನಿಷಿಯಲಿ ಓನ್ಲಿ ಇಫ್ ಐ ಕ್ಲಿಯರ್ ಯುವರ್ ಡೌಟ್ಸ್ ಐ ಕ್ಯಾನ್ ಸಾಲ್ವ್ ದ ಪ್ರಾಬ್ಲಮ್ very fast, like how we did in block diagram and mechanical system, how we did very fast so many problems like that. If you do it in basic is good means we can solve many problems. Just check out in other sessions, see how much your friends have done problems. More than that you people have done, no? That means because you know basics of that. Same thing here also. Basic ಗೊತ್ತಿರಬೇಕು. Basic is this diagram. ಇದು basic diagram. ಎಲ್ಲ ಇದ್ರಲ್ಲೇ ಇದೆ. ಟಚಿಂಗ್ ಲೂಪ್ ಯಾವ್ದು, ನಾನ್ ಟಚಿಂಗ್ ಯಾವ್ದು, ಸೆಲ್ಫ್ ಯಾವ್ದು, ಲೂಪ್ ಯಾವ್ದು, ಫಾರ್ವರ್ಡ್ ಪಾತ್ ಯಾವ್ದು, ಎಲ್ಲ ಇದ್ರೆಲ್ಲ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಸೊ ಇದ್ ಮಾಡ್ಕೊಂಡ್ರೆ ನಮ್ಮ ಪ್ರಾಬ್ಲಮ್ಸ್ ಎಲ್ಲ ಈಸಿ ಆಗುತ್ತೆ. ಸೊ ನಾನು ಇದೆಲ್ಲ ಅರ್ಥ ಆಯ್ತಲ್ವಾ? ಇಷ್ಟು ನಾನು ಹೇಳ್ಕೊಟ್ಟಿದ್ದು, ಇಷ್ಟುವರೆಗೂ ಹೇಳ್ಕೊಟ್ಟಿದ್ದೆಲ್ಲ ಅರ್ಥ ಆಯ್ತಲ್ವಾ?
Yes, ma'am.
Okay. Hope you people have rough book with you. Apart from control system book, do you have rough book with you? Rough book al barirappa. Notes, let it be in a flow. Whatever notes we have sent, that you write down. Let that be the notes. Now what you are doing here is just a rough work. Okay, keep some pages rough book you use. Okay. Now I told you in the beginning, we are going to solve the signal flow graph in two different methods. First one, we will give some equation and you have to find the signal flow graph. Second one is block diagram will be given and we have to find out signal flow graph. Okay. Once you find signal flow graph, what we are going to find out ultimately? Transfer function.
Transfer function.
This is not visible. Color is not visible. ಏನೋ ಹೇಳ್ತಾ ಇದ್ದೀರಾ, ಆದ್ರೆ ಏನು ಅಂತ ಗೊತ್ತಾಗ್ತಿಲ್ಲ. ಕಾಣಿಸ್ತಿಲ್ವಾ? Equation, you have to find out signal flow graph, then block diagram will be there, then you are going to find out signal flow graph. Ultimately we are end up in finding out the transfer function of the system. Okay, is that okay now?
Yes, ma'am.
Okay, now let's start doing it. Okay, first one. Yes, ಯಾರೋ ಏನೋ ಹೇಳ್ತಾ ಇದ್ದೀರಾ, ಗೊತ್ತಾಗ್ತಿಲ್ಲಪ್ಪ ನನಗೆ, ಕೇಳಿಸ್ತಿಲ್ಲ. ಏನ್ ಪ್ರತ್ಯೂಷ?
ಮ್ಯಾಮ್ ಯಾರೋ ಅನ್ಮ್ಯೂಟ್ ಮಾಡಿ ಮಾತಾಡ್ತಾ ಇದ್ದಾರೆ.
ಅನ್ಮ್ಯೂಟ್ ಮಾಡ್ತಿದಾರ ನನ್ನ?
ನಿನ್ನ ಅಲ್ಲ ಮ್ಯಾಮ್, ಅವರೇ ಅನ್ಮ್ಯೂಟ್ ಮಾಡ್ಕೊಂಡಿದ್ದಾರೆ ಅನ್ಸುತ್ತೆ, ಗೊತ್ತಿರಲಿಲ್ಲ.
ಓಕೆ, ನನಗೆ ಯಾರು ಏನು ಹೇಳ್ತಿಲ್ಲಲ್ಲ?
ಇಲ್ಲ ಮ್ಯಾಮ್.
Okay, now let's solve some problem. Okay, first thing is consider an equation. Some equation we will have. Okay, v1 is equal to 2 into vi plus 3 into v2. ಇದೊಂದು equation ಇದೆ. ಈ equation ನ ನಾವು signal flow graph ಹೇಗೆ ಬರೆಯೋದು ಅಂತ ನೋಡೋಣ. Okay, see, v1, v2, v3 ಎಷ್ಟು ವೋಲ್ಟೇಜ್ ಟರ್ಮಿನಲ್ ಇದೆ ಇಲ್ಲಿ? 3 ಟರ್ಮಿನಲ್ ಇದೆ. So I have to put 3 nodes, node 1, node 2, node 3. Okay. However I want, I can put, but direction should be very important. Now let me consider this as Vi, this node as V1, this node as V2. Okay. Now see this one, this part. First you have to start analyzing from. What is this doing? It is coming to this V1 with a magnitude of 2. Correct? With a magnitude of 2, it is coming to where? To V1. So from Vi, I am moving to V1 with a magnitude of 2. So V1 ಹತ್ರ ಏನ್ ಬಂತಿಲ್ಲಿ 2 into VI ಬಂತು. ಓಕೆನಾ? ನೆಕ್ಸ್ಟ್ ಈ 3V2 ಇದೆಯಲ್ಲ ಇದೇನ್ ಮಾಡ್ತಾ ಇದೆ? It is coming to V1. It is coming to V1. So V2 ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ? V2 also is coming to V1 with a magnitude of 3. ಇದು ಸಿಗ್ನಲ್ ಫ್ಲೋ ಗ್ರಾಫ್. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ ನಾವ್ ಇದನ್ನ ಅನಲೈಸ್ ಮಾಡಿದ್ರೆ ಇದು ಬರುತ್ತೆ ನೋಡಿ. ಏನಪ್ಪ?
Ma'am, say it again, ma'am.
See this V1, see this expression. V1 is equal to 2 times of Vi plus 3 into V2. So this 2 into Vi should come to V1. This Vi should come to V1 with a magnitude of how much they have given? 2 they have given. So I'm drawing a line. It is the direction is coming like this with a magnitude of 2. Similarly, V2, what should be the V2? Whether it is incoming or outgoing, you should see. See, it has to come to V1. When you add this, at this point, what is the expression we are getting? V1 is equal to 2 into V1 plus 3 into V2. Alva? ಇಷ್ಟರಿಂದ ಬರಿಬಹುದಾಗಿರೋ ಈಕ್ವೇಶನ್ ಇದೆ ತಾನೆ? You can write it in different way. There is no issue. See, now I will write it as, I'll write this as V1, this as Vi, this as V2 I will write. Okay. Now what I will do, to V1 I want Vi has to come to V1 with a magnitude of 2. V2, this node V2 should come to V1 with a magnitude of 3. ಅರ್ಥ ಆಯ್ತಾ ಇದು?
Yes, ma'am.
Yes, ma'am.
This is how we have to write. If the equation is given, this is how we have to write the signal flow graph. Okay, one more expression I'll give so that you can solve. You can understand what is that. Enamma? Okay, write down this. V3 is equal to 5 into V2 plus V0. For this, you write the signal flow graph. How many nodes I should write?
3, ma'am.
3 nodes I will write. Okay. I will name this as you want, you can name it, but only the direction should depend. Okay. This I will write it as V2 I will write. This is V3. This is V0 I will write. You try it in different way, whichever you want. Okay. Now, this V3. This V0 with a magnitude of 5 will come to this V3. Okay. Next, this V0 will come here with a magnitude of 1. Over? Over? Did you do it?
Yes, ma'am.
Hope you got it. Hope you got it?
Yes, ma'am.
Yes, ma'am.
Then everyone solve this problem. Okay, pa. Then solve this. Solve this. How many nodes I should put here?
3, ma'am.
Very good, very good. You can do it in different way. Wherever you want, you can put your node. But signal value, direction of an arrow map is important. Direction of your node is important. Okay, now. Done? This one?
Yes, ma'am.
You have done this also. Acha. Fine. So when equation is given, you know how to write the signal flow graph. Now, when block diagram is given, let us see how to write the signal flow graph. When block diagram is given, let's see how to write the signal flow graph. This is very important. Okay, give me some time to draw the block diagram. Wow. You have to draw, okay, this the graph you draw it in your book, ma. This problem you draw it in your book.
Ma'am, time up, ma'am.
Huh?
Ma'am, time up, ma'am.
I'm not leaving today, no. I'm going to continue today. I'm not going to leave you people. I'm not going to leave you people today. Today we are going to do this also and then go. Okay? Yes, I know, man. I know, time up. Okay. You draw this block diagram, okay? Get me a cup of coffee. Have you drawn? Once you finish it, just say me, inform me, okay? Those people who are using laptop, are you facing difficult? Is it in a horizontal, vertical order, something like that?
Yes, ma'am. Horizontal, ma'am.
Horizontal. Okay. Horizontal means no issue, I think. Alva.
Am I going to send the recorded videos for this?
No.
Ma'am, I'm already recording the class, ma'am.
Oh.
I can share the link. Your voice is muted, ma'am.
I tried to play that recorded video. It was informing me that you're not able to play. Not supporting like that, it was saying. How do you people do it?
No, ma'am. Like every class, I'll do that, ma'am. I'll send them the recorded class link.
Have you played that and seen it?
Yes, ma'am. We have to just log in using our Teams ID and password to watch the video.
Is it? Okay.
Yes, ma'am.
I tried opening, but it was saying that you're not able to download this or play this.
No, ma'am. In Chrome, we have to watch it, ma'am, not in the regular video player.
Okay. Later, when after this class, now I'll take your guidance to see that.
Okay, ma'am.
You sent it in the group afterwards. This recorded.
Okay, ma'am.
In the EC 4th B group you sent.
Okay, ma'am.
Okay. Fine. You have taken down the block diagram.
Yes, ma'am.
Okay. Okay. First step. Let's start writing it. First, you have to name the input and output. Okay. Next point. You have to name all the summing point and takeoff point. You know what is a summing point and takeoff point now, right? Am I right?
Yes, ma'am.
So this one I will name it as S1 is my summing point, and this summing point I will name it as S2. You do it along with me. You write summing point and takeoff point. You write summing point S1 and S2. I will name. Takeoff point. This is one takeoff point, right? I will name it as T1. And this takeoff point, I will name it as T2. Need not write this because that is same as T2. Have you named T1 takeoff point and summing point?
Yes, ma'am.
Yes, ma'am.
Okay. Now, this is step 2. Okay. Step 3, what we are going to do is all the input and output, takeoff point, summing point, all these 4 things I'm going to represent in terms of nodes. I'll repeat: input node, input terminal, output terminal, summing point, takeoff point, all these things I'm going to represent in terms of node. Okay, now, see, let me write first node. This is my input node. Okay, then see this from input to, okay, from this to S1 I have to reach. So next node is my S1. Okay, I will travel like this. How much is my magnitude here? From this to this, I have a magnitude of 1. Okay, then from S1 to T1, I have T1, another node I have to put. Okay, this is my node T1 here. See this point, this T1, S1 to T1. Okay, I have a gain of block G1. I have a gain of G1. Okay, next T1 to S2. See, next node is S2. From T1 to S2, I have a gain with, okay, I have a gain of G2. Next, from S2 to T2, I have another node T2 here and have a gain of how much is this? G4. Then I have output node. Is this clear? This part of work is clear?
Yes, ma'am.
Yes, ma'am.
I did input I made it node, output I represented the node, all the summing point I represented it as a node and named it. First I named it, then I put them in the form of nodes. Okay, takeoff point also same way I did. Okay, now what is left out? This loop is there, this loop is there, this we have to fill that. Okay, next, see, from T1 to to S2, I have another one path here. From T1 to S2, I have a path here. The direction is given. It should reach S2 with a gain of G3. ಅರ್ಥ ಆಯ್ತಾ?
Yes, ma'am.
Okay. Next.
Yes, ma'am.
Next. T2 ಇಂದ ಒಂದು ಲೂಪ್ S2 ಬರ್ತಿದೆ. T2 ಇಂದ ಒಂದು S2 ಬರ್ತಿದೆ. Direction is it should go to this S2 direction ಹೋಗ್ಬೇಕು. ಮೈನಸ್ ಸೈನ್ ಇದೆ. ಇಲ್ಲಿ ಎಷ್ಟಿದೆ ಗೈನ್ H2.
H2.
ನೆಕ್ಸ್ಟ್ ಏನಿದೆ ಇಲ್ಲಿ T2 ಇಂದ S1 ಗೊಂದಿದೆ, T2 ಇಂದ S1 ಗೊಂದಿದೆ. ಡೈರೆಕ್ಷನ್ ಹಿಂಗಿದೆ, ಮೈನಸ್ ಸೈನ್ ಇದೆ, H1 ಇದೆ. ಫಿನಿಶ್. Is it not so easy?
Yes, ma'am.
Block diagram is given. When any block diagram is given, first what you have to do, name the input, summing point and the takeoff point. Again, you have to name them. How much ever summing point is there, name them S1, S2, S3, S4 up to infinity. Okay, then all the takeoff point you name. Then input or input, output, takeoff point, summing point represent in terms of node. ಆ ಬ್ಲಾಕ್ ಒಳಗಿರೋದನ್ನ ಗೈನ್ ಹಾಗೆ ಕೊಡಿ. ಫಿನಿಶ್. ಫೈನ್. ಇಟ್ಸ್ ಈಸಿನಾ?
Yes, ma'am.
ಅರ್ಥ ಆಯ್ತಾ? ಓಕೆ. Now I will give one block. You write the signal flow graph for that.